This week, we discuss the security benefits and dangers of testing code. In the news segment, Pwn to Own hits hardware products, a logic flaw hits a stock trading app, Chrome hits back at heap corruption, and more. Stay tuned for Application Security Weekly.
This is a Security Weekly production. Make sure your team is prepared to fight off the latest cybersecurity threat. IT Pro TV is the resource to keep you and your IT team skills up to date. You can stream IT Pro TV courses live and on demand, so there's no need to send staff to off-site training. Team subscriptions include Pro Portal, so managers have full control over your team's training schedule. Go to itpro.tv/ASW and use the code ASW30 to try it free for 7 days and receive 30% off your monthly membership. Signal Sciences secures the most important web applications, APIs, and microservices of the world's leading companies. Protecting over 7,500 applications and 150 billion production requests per week, Signal Sciences Next-Gen WAF and RASP help companies increase security and maintain site reliability without sacrificing velocity, all at the lowest total cost of ownership. Signal Sciences' patented technology protects any application against any attack, with integrations into any DevOps toolchain. Signal Sciences, demand more from your WAF. Learn more at signalsciences.com/PSW.
Welcome to Application Security Weekly. This is episode 84, recorded November 11th, 2019. I'm your host, Mike Shima. I'm here with Matt Alderman. Hey, Matt.
Hello. It stopped snowing, finally.
It stopped snowing. We've also got John here. John, what's the snow report over on your end?
Snow here in my part of the Bay Area. I don't know about up where you are, but...
No snow, no rain, a little bit of smoke, a little bit of fire. So, yeah, not too exciting. Register for one of our upcoming webcasts with Bryce Schroeder and Barbara Kay of ServiceNow, Kevin O'Brien of Greathorn, or Steve Lobenstein of Core Security, or all of them by going to securityweekly.com. Click the webcast dropdown and select registration. If you have missed any of our previously recorded webcasts, you can find our on-demand library by selecting On Demand from the webcast dropdown. If you attend any of our webcasts, you will receive 1 CPE credit per webcast. We're currently running our annual listener feedback survey. Please visit securityweekly.com, click the Survey tab, and select 2019 Listener Survey to submit your responses. We don't have a guest for this segment, but we do have a good topic, as we always hopefully have good topics on Application Security Weekly. One came up from a comment on Twitter. One of the listeners reached out to me and asked the question, we know that we're supposed to be testing code, but a lot of testing our code needs to be tested against data. Lots of times, data that might be production data that might be in production, and therefore also needs to have strong controls around it, whether they should be encrypted or have tight access controls. And if we're trying to test against that same kind of data within a staging environment or even on a development environment on local laptops, those security controls aren't as easily enforced. So one of the things I wanted to do today was talk about a couple of the aspects of testing code in general, why we do it, what are the ways that we can sneak security or just build security in that testing phase of the CI/CD pipeline, and also talk about different strategies when we need to go beyond just unit testing and into full functional or even system testing when we need to operate on large amounts of data. So to sort of set the aspect, or to set the stage first, we'll step back and maybe talk a little bit about some of the security testing we've talked about on a couple previous episodes. One, for example, very security focused, is fuzzing. And fuzzing is one of my new favorite types of testing. That's because it's basically saying we're going to trade off manual analysis for a whole lot of CPU time by throwing random data into our applications, see what happens, and when they crash, either figure out that crash is exploitable in a security problem, or it is something that is just a bug that needs to be fixed in general. But I don't know if Matt and John, in the way that you've been working with engineering teams to build apps, if they have particular testing strategies that have, even started off with security testing from the beginning, or does that come a little bit later when they're more mature?
What I've seen recently, my favorite way to do testing like this without worrying about having my production data be involved is if I can get production data from my competition and use no. Um, I think really what's really sort of value here, the fuzzing is great, I think, and I would actually personally recommend people not to get too excited about that off the get-go, right? You have to do a lot of the basics beforehand. Once you've actually gone through and have a relatively mature AppSec program and you have like some of the unit testing, some of the other stuff we're going to talk about, I think then you can go back and start thinking about fuzzing once you've found some of the more low-hanging fruits. Because a fuzzer sounds great, but when you actually try to get the guy up and going and figure out what do you fuzz, what type of data do you fuzz with, how long do you fuzz, all those type of things, sort of, there's a lot of variables there. So I would say, it's, it'd be interesting to see. This is the same sort of problem we're seeing with machine learning. It's like, how do you, machine learning, got to use hands. But how do you do this? How do you do that, either the training or testing in non-prod, but having that same data set, have enough data in there that's usable to reflect how your product is set up or how your application is set up, but also not have anything that's sort of being disclosed. So I think, you can do it with some tokenization and things like that. I haven't seen a product out there that helps with this, so I think someone has to have their hands on the data to be able to set that up, or you can create your own. I think what a lot of younger companies do, or younger projects, is actually create that data set yourself. That's fine until a customer comes along and has an idea that you didn't. So you need a balance between those two type of things. When I first got to Qualys here a year ago, one of the systems, I won't mention which one, but one of them, the username, and it's not a Qualys system, it's something one of the vendors we use. The username is obviously somebody was trying to do either cross-site scripting, or actually, it was a SQL injection they were trying to do on one of the fields. And like a year later, that data is still there. So it's, okay, nice try, clean up after yourselves, but let's not do that in that type of environment. So there's a lot of things there to be played with, preferably with, some data that's not production, I think let's start there.
And that's a good point. And I always love to jump to, I get attracted by the shiny, cool things that are fun, like the fuzzing testing. But when you're describing ML, hands, that's a really good point, because that's the actual type of testing and type of development that relies heavily on data, and quite often on a lot of personal data, or PII, or the type of data that will come under compliance restrictions like GDPR or CCPA. And so one of the ways I've seen is that you can building, I guess let me step back a second. There's two aspects. One is training the model, like you described. And then, of course, there's also just executing, seeing how the application is working. That training the model is interesting because depending on the context of what's being built, you don't necessarily always need, or let me say it this way, you can possibly just use dummy data and generic data, but you need to have, or data that could be cleaned up a little bit. Let me say it that way. So if you're operating on phone numbers and email addresses, you don't necessarily need valid and live email addresses. They could always be abc@emailaddress.com, or 555-1212, but it's where that semantic location of those values fall within like a phrase might work. And this will be something, for example, when ML applied to natural language programming, things where you're trying to build chatbots or those types of scenarios. So that's where the context of it is. You may be interacting with a lot of potentially personal data, but you don't necessarily need that really personal data to be part of your test corpus. All the names could be turned into Alice and Bob and Mallory. They don't have to be the full names in order to be able to say hello or goodbye and interact with it. So that obviously is very context specific and doesn't generalize too much. So I will say, going back to that idea of tokenization, though, I haven't really seen any commercial offerings like that have been either well adopted or particularly successful.
Yeah.
So it definitely remains a challenge.
Another thought you just made me think of, which I've seen young companies and young projects do, is we won't use production customer data. We'll just use data from ourselves, all the employees. Again, okay, you're testing on yourself. Sounds a little bit more sane, but the three of us were on Business Security Weekly also earlier today, and one of the things we were talking about was, for a CISO in a large organization, part of their areas of how shall I say concern is protecting not just the application and customer data, but also protecting the enterprise's data. So don't think that's a shortcut, please.
Yeah, no, not at all. And I think there's always there's always the idea of, well, what if we just release the code and test it in production, right?
But so Mike, to my point, but this is how we started this whole thing. If we think about
Right.
what we used to do, development would develop, they'd do their QA testing, they'd put it into production, and then the security team would come along, take a beautifully crafted web app scanner developed by who, and throw it at the app. And we'd go out and we'd find SQL injection and cross-site scripting and all the OWASP top 10, right? That's how we used to do it. I mean, that's literally how this used to be done. And then we realized, okay, black box testing is, okay, I get maybe a lot of false positives because I don't understand the app. So then it was like, hey, how can we shift security testing to the left, right? And we've been talking about shift left for 10, 15 years and trying to push that back. So now we're like, all right, we're going to do static analysis as soon as the code's built. We're going to run a SAST at it, and maybe some fuzzers in the code in the IDE. Then we're going to do a software composition analysis, and then we're going to throw it into staging. Think about what we've done, right? And the reason I brought that up is a small organization who is out building an application. This is kind of the process that you're going to go through, right? You're going to build enough functionality and enough unit tests to test the functionality of your app. Then you're going to worry about security later. Because now you got that thing running, you have customers, you're like, uh-oh, I better secure it. So where do you start? Do you start with the running code that's already in production because it's potentially vulnerable? Or do you kind of reinvent the entire DevOps process and go back and say, well, how should I implement a fuzzer and a SAST and a software composition analysis and then a DAST and all the other things that have to happen, right? This is not an easy answer, by the way. I'm just saying this is traditionally how this stuff kind of happens.
Yeah, I think you're really pulling out too. One of the implications in what you're describing too is that I'll use the word DevOps, is that's also embraced the idea that you can't just write code and then hand it over QA, let them poke at it, find all the problems, send it back to you, and then you throw it over the wall for the operations team to deal with in production and to find new and wonderful different bugs. It's the DevOps, those teams are becoming responsible for that end-to-end deployment as well as this testing. So one of the ways is that, and again, too, I'll not quite actually jokingly say, there are ways to approach testing on production data. And I'll say that in the sense that there are benefits because production data, you have scale, so you're often going to hit boundary conditions. If you're only testing on, if you only have, 3 or 4 employees to go for, like, how John was describing, approach test on yourselves, you're not going to hit those same problems when you get to 1024 or 10,000, or, you go over perhaps a gigabyte of storage or a gigabyte of addressing. You start to run into subtle calls. But what I was going out with this idea to come back and talk about, do you touch production, is, Matt, you were just describing building up unit tests over time, building confidence in deployment. Also, part of that can be building deployment strategies, meaning you can have A/B testing, or you can have feature flags to say, here's a code change, and it's actually it's going to collect new data. So it's going to add new data into our database. You could roll that out, make sure the code itself is working, that all the original code paths aren't affected by it, and then feature flags, slowly roll it out and turn it on for 1% of your population, 2%, 5, 10, and so on, so you can see how the application is reacting to it. And if you have that type of maturity to be able to to feature flag these types of things, turn them on, then back off, and be able to have application level monitoring, feedback loops, that's not necessarily a bad thing. And you're not necessarily, you're exposing some, your production data, especially when these can be changes that are changing data. So updating the database, adding new fields, something like that. Also, the other thing I guess you want to say is make sure you have backups so that you can store as well.
Yeah, I mean, so here's a perfect example, right? Paul has been going through this as we've been developing our own internal application. And you got to remember, this is an application that's been built over the years and different developers, and Paul's kind of really wrangled it over the past year or so, really to improve our operations. And think about this for a sec, right? I mean, you have this existing code base, you're making improvements to it, and you're trying to do the right things from a security and a testing perspective. So where did we start? We started with unit tests because we needed to unit test the application for the new functionality. And so, you start to build the unit tests so that they're built into the pipeline. So whenever we go from dev into staging, a set of unit tests can run against it to do regression testing to make sure that major functionality that we want in the app didn't break when we added this new feature. Then you push the thing to production and you go on your merry way. Well, Paul ran across an issue, and I've brought this up before, where he accidentally bypassed authentication in dev, and it got pushed to staging, and then it got pushed to production. How do you catch that, right? And so that's a new unit test that you develop that says, oh, let me make sure that authentication is working correctly. Let me create a scenario of a valid login and an invalid login and make sure the invalid login fails and doesn't go through, right? And so over time, what you start to build out, if you do this right and you do it as part of your pipeline, is that you continue to add a series of unit tests that also include security tests to test for major components of the application and functionality to make sure there's no regression or somebody didn't leave in keys by default or bypassed authentication or whatever those things are, right? And the beauty of DevOps, I think, is it allows us to make those integration points and continue to add those in a very automated way such that we don't have to lose control of the application and send it to QA, then send it to ops, then send it to security. It's just literally happening at these different stages across. And if anything fails, gets back into the developer's hands very quickly. They make the fix and off we go. Then we can start to add in other types of tests into that pipeline in a very similar way to look for fuzz. You can add your fuzzer. Now you can add your static code analysis. Now you can add your this, that, and the other thing. And it all starts to come together in this beautiful pipeline. And guess what? You could be using production data as part of that pipeline. It's just you got to make sure that you know where those environments are running and make sure that the right security is around those environments to protect any potential, production data in those environments.
Yeah, so that's where. Oh, go ahead, Matt.
Yeah, one thing I want to call out there specific what Matt was just saying. I think most of our listeners will understand, but some might. So I just want to make it very clear. A unit test doesn't always have to have a positive response. Right, that sounds super simple, but I think to some people who are still learning how to do some of this unit testing, especially from a security point of view, sometimes negative is actually what you're looking for, like that authentication failure.
Yeah, I think the authentication failure is a good example too, to say to interrogate your test framework, meaning does it actually have the capability to be able to do a login test? Can it actually go from a black box perspective? Can you can you run a headless browser, log in with a username and password that's correct so you can confirm it's working? And then can you log in with a username and a clearly invalid password? And does it still work? If you have a test framework that can express that type of sequence, that's pretty awesome. If you find yourself having to do one-off building the here's how to make the web request for this, here's how to find the form. That doesn't necessarily generalize, and that's kind of what I'm getting at, because if your test framework then also makes it difficult to add some cross-site scripting payloads or some SQL injection payloads and observe the behavior, then maybe you do need to go to a different tool that's purpose-built for that. A commercial tool that can do that is more of a SAST or DAST approach. But it's a different way. It's also a way to say, we've been using unit tests, I think, as a bit of shorthand for all of the testing, and we've kind of avoided or not quite mentioned what a testing framework can handle and how it actually interacts, whether it's the full functional testing of a particular workflow or what have you, things like that.
Right. Testing frameworks are important because the integration of the different tests and the different tools that you might need to support those, right? And that's where you can bring in some of the different security testing tools, hopefully, into that framework so that you can actually validate aspects of the security functionality, not just the application functionality.
Right, and that's where it goes back to yet another good common theme is if you can bring those tools in and they're API driven, that's even better, because that means, like you were saying, Matt, you can just plug them in all throughout that continuous testing pipeline, and so we don't need to go through this stage, this team, and so on. They can just run in parallel, in series as needed, but they can be instrumented, so they're opening a Jira ticket or they're making a comment on the pull request associated with the latest commits being tested. All of those are great strategies, again, to not only test the code, but bring the results of testing right back to the developers, and ideally the developer that was most responsible for the recent commit that caused a problem, since that's the person that would also be the one both knowledgeable but also probably responsible for having to fix it.
Yeah. And that requires a level of maturity and sophistication in your pipeline, but that's ultimately where the stuff moves to. And that makes it easier, I think, to include security tests as part of your overall set of unit tests, as part of that pipeline of pushing code into production.
It is, and I think, and the other part of what you were saying earlier too, as you're describing that scenario, we talked about the login testing, but testing against production data, it can be done in a reasonable way if you still have those same access controls and trust boundaries around it. Obviously, you have more developers there may be looser access in terms of the type of code that can be committed and operating on that data, but that data could still be isolated in its own VPC with no egress. So it's going to make it a lot harder to leak either by accident on purpose or through a type of bug. And, plenty of cloud providers have these types of components to do that. So some smart network design, some smart CI/CD design can also be more accommodating to be able to handle those types of situations as well, as long as you have a good idea of what can humans touch and what are the differences between someone SSHing into a container just to muck about a bit, do some debugging, versus they can only do that in prod if they go through a Bastion host and they have 2FA enabled, those types of things, because having 2FA and staging should be just as easy, especially with YubiKeys. OpenSSH just a couple weeks ago released support for hardware for FIDO tokens as well. So there's a lot of ways that we can have access controls still be pretty strong without sacrificing security.
Yeah, and one point I want to make on that thing is I don't think anybody should be SSHing into production to make a change. Part of the reason the DevOps pipeline exists is that you can make those changes quickly and move them, because the potential downside of allowing that to happen in that particular case is you have now drifted away from a known configuration that you can restore to, because you changed it in production, but who went back and made sure that that same configuration setting was changed on the development side as part of the next push, right? And so if you get your processes to the right level of maturity, you're actually making those changes as part of your CI/CD pipeline and pushing that change out instead of allowing people to actually touch production and make that configuration change, because that's where organizations, I think, get in a little bit of trouble, because now what's running is not what's the last known state of the code. And when you go to restore or something like that from a resiliency standpoint, you just defeated what was immutable infrastructure at that point, right? So I think there's some cautions there, is that you would want that same process to exist pretty much all the way through, including production.
Yeah,
Absolutely.
I'll have to say I'm really I'll say uncomfortable with the idea of allowing, production data anywhere outside of production for testing, even if it's a super secret hard location. I don't have that much faith in humans. I really like the idea of using feature toggles. I think more people should be using those. Either build your own or use, Launch Darkly always comes to mind, or pick whoever else is out there. But that to me is like, if you want to do testing in prod with that, that's the route that I would usually go. And then the second thought that came to my head was, so we're talking about not using prod data for testing, but what can you take from prod? So is there metadata that you can look at that, right? Okay, so how many customers do you have? Do you have on the order of 500, 5,000, 5 million? So I think from a lot of the things that are out there, maybe you can take some of the metadata from that and actually bring it back into your testing program. Is there a certain part of your application which either, generates more money or gets more attention from the users, gets more activity? So I think you might want to test those, because those are the really more active parts of the application, and the money makers. But at the same time, that can also say, when you take a step back, hey, we can't forget about these other 5 parts of the application. They might not be used every day. They're only used in tax season or Christmas, what have you. But we need to make sure that those are still tested and ready to go for when we need them.
Yeah, I think that's a great way, because that kind of speaks to coverage, I think, a lot too.
Yeah.
And that's the challenge for even for a SaaS tool, DAS tools, all of these, even with unit testing, how much of your code is instrumented. And I always, when talking about testing code, SQLite has a fantastic test harness, and it has a pretty well documented philosophy behind how they approach their testing. They have a great explanation of how they instrument their code for the testing in a lot of many different ways. So it's heavily tested code. I can't remember off the top of my head. I forgot to look it up before this, but it's something like a ratio of like 1-3 or 1-5, I think, is the number of lines of code to the number of tests that are run against the code. Wow. And it's really impressive. And so I want to build it up and say that is a great reference just to learn about an approach towards software testing. But despite that, it has still had a handful of vulnerabilities reported. Now, that's not to say the testing was inadequate. I'm more highlighting that in the sense of check out SQLite and how they do their testing, just from the ideas of their approaches. And to add to John's poor faith in humanity, there are going to be some bugs that slip through. What's good, however, is that if you have an approach that's pretty formalized, or that has a good process behind it, when you hit that flaw then can hopefully just be identified as a small blip in your process that can be filled in, rather than demonstrating you had a complete lack of awareness of an entire bug class, or you have no way of instrumenting a certain type of bug class. On the other hand, you have no way to check for CSRF, for example, things like that. So I just wanted to throw that out there too, as a I guess I can't quite call it a homework, but some exciting reading for those of you who like looking through testing code.
There is no foolproof testing process out there. Every software is going to have a vulnerability, a bug in it somewhere. The question is, can I address the 99+%, deal with the edge use cases, automate those where I can, and get even more secure as part of my process? And if the answer to that is yes, then we've made progress as an industry. So, it's going to happen. But what you hope is those are the corner cases. They get integrated and everything gets stronger and stronger and stronger, but we'll never get to 100%. We just won't.
Yeah. It's a cost center, right? So, I mean, you have to, it's almost a bit of a science or art if you're doing it right, of like, are we spending just enough money to make sure that the code is just secure enough for the average value or maybe the high end value of the users using it in either their data or whatever that CIA requirement is. I don't think I've mentioned on ASW. This is one of my favorite things from like last 20 years. I tend to talk about a lot. Article called "They Write the Right Stuff." Is it in Forbes magazine, if I remember right, or Fast Company? It was an article talking about back in the day when the space shuttle was around, the trouble those guys would go to for every line of change they would make in that software. I think it was Lockheed Martin, and they'd basically talk about back in the days of printouts, they'd bring a binder into a room, in a conference room, they'd highlight the line they're thinking about changing, and then they'd actually sit around and talk about it. We can't all do that. So, right, and we're not all flying space shuttles. So what's that balance between those sort of two ends things out there that's really what this comes down to.
Yeah, and I think that's a great way to sort of broaden and maybe we'll put a pause here and talk about the broader SDL later on. But you just started to describe threat modeling right there,
yeah.
And you're absolutely right that we can't do that for every single line of code. But it's a great behavior to build. It's a great thing that security teams can go through those exercises and work with DevOps teams about threat modeling and think through, because as you start to instill that thought process, then ideally developers will start to internalize it and think about what's going to happen if I make this change in the code. And some of the times that what's going to happen is performance. Some of the time is going to be data integrity. Other times it's going to be security. And hopefully, all of those three things are important. And together, they'll just build more robust, resilient code. Cool. So I think with that, we at least tested. We hopefully didn't test your patience, dear listeners, but hopefully we did test your thinking about how to approach different ways of approaching design or testing your code. Because we assume, in addition to the well-documented code that we knew everybody's doing already, we figured that everything's well tested as well. And on that note, we're going to take a quick break, and we'll return with news of the week.